Yeah, drop, hey, huh.
Yo, what's up guys, this is 𝗪𝗚𝗟𝗟𝗟 and today we're playing 𝗪𝗘𝗥𝗘 from PicoCTF, another binary exploitation challenge, and spoiler alert, another format string binary. So let's go, we download the files here, and we have this, flag is just mine, and let's review the source code. So right here we see that we have a win function, nice, that reads the flag but never prints it, okay. And then we have under construction that has some uninitialized buffers and pointers, and after that it does printf user information %p b, and we see that it starts printing this stuff that are uninitialized. That means it will probably print junk or whatever lies on the stack this time, and yeah, all of this stuff the same. And here we have a massive buffer overflow with gets, you know the drill, man gets, and you say that do not use this function. So yeah, I think that's it for now, and let's check the protections. And we have, so it's 32-bit binary, partial relo, we have canary, and next enabled and no pi, okay. It's kinda sus that it has canary file. Okay, so it's statically linked, that's why it looks like it has canary, but in reality it doesn't. We can also check that again inside the debugger, so cyclic, let's say 40, seems like a small binary, and we run, and we see that the EYP has this address here. And we see that the offset is 14, cyclic-so, and the offset we found. So we know our buffer overflow offset, where we override the return address, and we have a function that reads the flag and it will probably save it on the stack, and after that we have a function that prints many variables, so apparently things that are on the stack, so the flag. And this is our goal, overflow the buffer and then call win to read the flag, and after that under construction to start leaking stuff. I have made this template. Here I have a helper which says that p in hex is 0x70, I is 69, yada yada, and this is the start of our flag. So if we find these values when leaking, we know that we are in a good way. So let's go here, we have 8 times 14 plus p32, because we are in a 32-bit binary, p32 e.sim win, and then we have p32 e.sim under construction, and this shall start spitting the flag hopefully. So let's spawn an instance. So we run the solver, Python solver, and we see that we start getting some leaks, and we see 70, 69, 63, 70, 69, 63. So this is the start, and it ends at 7D, which is right here. So if we take this, and let's go to 𝗪𝗟𝗟𝗟𝗪, because I'm too lazy to do it by hand. We put them here, and remove this, and add this here, and our recipe should be from hex, and we see that we get the flag this way. We also need to reverse, and nice and clean, we see that we managed to get the flag. So that was a challenge, guys. I hope you found the video useful and helpful. If so, leave a like and subscribe to the channel to support me, and see you in the next one. Bye.